Now, picking up where the last one left off, I'm seeing a pattern here. And that pattern is that when I have x plus a number squared, and I distribute, I'm going to end up with x squared plus 2 times my number times x plus whatever number I had squared. So the bottom line is, if I can identify this pattern, then I know that it's going to be able to factor to be this perfect square. Let's try a few more examples. X squared plus 10x plus something equals, a factor squared. So I think, that middle term must be 2 times the number I'm interested in. So in this case, the number I'm interested in must be 5. That third term must be 25. And the term that it's going to factor to be is going to be x plus 5. Now let's look at x squared minus something times x plus 16, and this is going to equal a factor. Now I know that that third term is the number I'm interested in squared, and that the second term is 2 times my number. So if 16 is my number squared, then my number must be 4, because 4 squared is 16, and in this middle spot I need to put 2 times my number, so I need to put 8. Now this factors to be x minus 4. Notice that there was a negative there in front of the 8. Alright, let's take a look at x squared plus 9x plus something equals some factor squared. Now, this time I'm interested in half of my middle number, but it's not exact, 9 is not even, so half of 9 is going to be a fraction. That's okay, I can handle it. Half of 9 is just 9 halves. Now I've got to think, to put in that third blank, I need to square my number. And my number was 9 halves, so I need to square 9 halves. Well, when I square the numerator and the denominator, so 9 squared divided by 2 squared is going to be 81 over 4. Let's try one more. X squared plus something times x plus 144 equals my term squared. Well, the number I square to get 144 is just 12, so my middle term must be 24, and my factored form must just say x plus 12. Now there's one more type that we need to address when we talk about perfect squares, and that is things that say x squared minus 81. Now this has come up before. This is called a difference of squares, and you're going to have the same number, but it's going to have opposite signs. Notice that I have a minus 9 and a plus 9. And when you multiply, if you were to multiply these two binomials together, their middle terms would cancel out, and you would have x squared minus 81. X squared is a square, 81 is a square, and that's why they're called a difference of squares.